the wood, not the fastener now. Okay, failure due to the wood. So when we say failure due to the wood, where do we actually mean? Okay, so failure due to the wood, okay, it means failure occur at the centroid. Okay, so this is our centroid. Means that failure occur at the where? At the centroid. Okay, so when that's the case, again, we know that tau max given to us is equal to what? Given to us is 3 times 10 to the power 3 psi. Okay. So now we have to find our Q max, which is equal to we calculated the first one, which is equal to 168 plus. Okay, so 168 is for the member over here. Then now it goes through the what? It goes through the plywood. Okay, so left and right 2. Thickness is equal to 0.5. The depth is equal to 10 plus 2 plus 2 is equal, no, 5 plus 2 plus 2. Right, so this is 5 plus 2 plus 2 multiplied by 5 plus 2 plus 2 multiplied by half. Because this is width, depth, this is the y bar. Okay, so from here you get 168 plus 5 plus 2 plus 2, 9 squared times by 0.5, 40.5. So this is equal to 168 plus by 40.5 is equal to 208.5 inches cubed. Okay, so now you just need to plug in the formula. Okay, now we just need to plug in the formula. Let me delete all this. Again, you can see like all the analysis we do down here, first moment of area is the most critical thing, right? So you have tau max is equal to VQ over IT, right? So this is equal to 3 times 10 to the power 3. This is equal to V. Q we just found out to be 208.5. Second moment of area is 2902. You have left and right web, and the thickness is equal to 0.5. So V over here will be equal to 3 power 3 times by 2902 times by 2 times by 0.5 divided by 208.5 is equal to 41.755 times 10 to the power 3 pounds, right? So we know that V is equal to P over 2. Therefore, P is equal to twice times by 41.755 times by 10 to the power 3 is equal to 83.510 times 10 to the power 3 pounds. This is failure due to the shearing force or allowable shearing stress of the wood. Right? So that is why, right? You see the force required to break the wood, and then you see the force required to break the joint, right? It's so much lower. Not this one. This value over here. This one over here, right? It's so much lower. So that's where if you're going to break something, okay, go for the joint, right? Right? Don't go for the body, okay? Go for the joint. And then the last one, okay, so failure due to bending moment, right? So you know that stress allowable, this is equal to 8 times 10 to the power 3 pound or psi. So you work this is stress allowable is equal to mz over by izz multiplied by y. So we know that mz, the stress allowable 8 times 10 to the power 3. The izz is 2902. And then the y is the distance furthest away from the centroid. Okay, so we look at here. Right, the y is the furthest distance away from the centroid, and this will be equal to 5 plus 2 plus 2 is equal to 9. Okay, so 8 power 3, that's why 2902 divided by 9. Wait, 8 power 3, that's why 2902 divided by 9. So the moment is 2.579 5796 times 10 to the power 6, okay, pound each. Okay, so if we were to draw, okay, if we were to look at the cross section of our member again, right, and we are going to stop our analysis, right? This is equal to P/2 at point A, right? And then we're going to assume this is our member at point A, right? And then we know that the distance from here to here is 4 times 12. Okay. So we're going to do static analysis, right? Dimension of moment Z is equal to 0. So we have P/2, or that is going in the clockwise direction, minus P/2 multiplied by 4 times 12 plus, right, it's going anticlockwise member of A is equal to 0. Okay. So moment at point A is equal to 4 times 12 divided by 2 is equal to 24p. Okay. Now, from here, we know that member at point A should be equal to 2.5796. So this is equal to 2.5796 times 10 to the power 6 is equal to 24p. So therefore, P is equal to 2.5796 power 6 divided by 24, which is equal to 107, okay, which is equal to 107.483 times 10 to the power 3 pounds. And this is due failure due to the normal stress, right? So therefore, the P allowable, you pick the smallest one. The P allowable and the smallest one is equal to what? Is equal to 6910 pound force. Okay. Now, what you see down here, okay, you realize that, hey, we are now combining normal stress, shearing stress, and also force resistance of the fastener. Okay. 3 different topics in one question. Okay. So in your exam, you're going to see questions like this. That's where writing of summary sheet is very important. Okay. It's not difficult. By no means it's not difficult. It's just remember 3 different approaches to calculate values that you need to make decision of. Okay. This is what road engineering is all about. Okay. Okay. I'm going to stop here. I'm going to see you guys again tomorrow. Last Friday, I have to cancel the lecture. It's because my pen for writing ran out of battery. Okay, and I did not have a battery, which I do apologize. And I hope you do watch the video. If that's the case, I see you guys again tomorrow. Okay, and I realize that I have a chat down here. Okay, we're okay. See you tomorrow then. Bye. I'll still stay behind if you have any question.